Okay, here's problem 1 from the Chapter 16 review. So first of all, we're given a function. We're not given the equation, just the picture. And it's only defined between -4 and 3, so these are endpoints. It's not going any further. The graph has a local maximum when x is equal to 0. So when x is 0, that's a maximum. It has a local minima when x is -3 and x is 2. So it says draw the first and the second derivative on the graph. I'm actually going to make myself a sign diagram first to get myself organized. So if I were to graph the first derivative, so I'm going to call this the first derivative, I'm going to take my maximum and minimums, and those are going to be my x-intercepts. So I'm going to have -3, I'm going to have 0, and I'm going to have 2. And then I'm going to look at the slopes. So here I have a negative slope, and then at -3 up to here I have a positive slope up to 0, and then between 0 and 2 I have a negative slope, and then I have a positive slope again. Okay, so that means on my first derivative I'm going to have negative function values up until -3. Then I'm going to have positive function values until I get to 0. So it's going to have to come back down. Then I'm going to have negative function values until I get to 2. And then I'm going to have just positive function values going on up. Okay, so that's what it's going to look like. So now I can put it over here. So I know my x-intercepts are going to be at -3, 0, and 2. Those match up with my maximums and minimums. And then I already figured out what my slopes are. So it's going to start at -4, it's going to come up, it's going to stay positive function values until here, so I'm going to go something like that, and then it's going to be negative function values until I get to 2, so something like this, and then positive function values until I get to 3. And it's not defined after that, so I can go ahead and put endpoints on it. Okay, so there's my first derivative. Now my second derivative. So to do my second derivative, I'm going to look at my first derivative that I just graphed, and I'm going to have to kind of guess as to what the maximum and minimums are of my first derivative. So here's my first derivative. It might be helpful to highlight it so I can see what's going on here. Okay, so in order to draw the x-intercepts of the second derivative, I look for the maximum and the minimum of my first derivative. So I have a maximum, it looks like at about -1.5. And then I've got a minimum, it looks like at 1. So now I'm going to look at my slopes. My slope before the -1.5 from here to here is positive. Then it's negative. And then after 1, it's positive again. So if I were to graph this, this means I'm going to have positive y values, then negative y values, but I kind of come back up to the x-axis and then positive. So like that. So now I'm going to graph that onto the original. So I'm going to have, it looks like I'm going to have x-intercepts at -1.5 and positive 1. And I'm going to have positive values, and then negative values, and I got to come back up to here, and there it is. Okay, I don't have any more specific information, so I can't really figure out how far down this goes. I could have made it go farther down, or more shallow, or less shallow, but there is my second derivative. So here's my second derivative. And in orange, I have my first derivative. Okay, so I drew those. Write down the x-intercepts of the graph of the derivative function. So my x-intercepts, those I know for sure because those came from the information they gave me here. So x equals -3, 0, and 2. Write down all values of x for which the first derivative is positive. So it's positive between -3, oops, need the equal sign, -3 and 0, and when x is greater than 2. Okay. At point D on the graph of f, the x-coordinate is negative 0.5. So negative 0.5 on the original graph would be right around here. Explain why the second derivative is less than 0 at point D. So here's point D. So why would the second derivative be negative at point D? Because it's concave down. Okay. The second derivative, this is concave down. Oh, actually, I should say the original function is concave down. Sorry, f of x is concave down. Therefore, f double prime of x is negative at x equals negative 0.5. Okay, and let's see. I think that's what we need to say. Just talk about the concave down. All right, that's problem 1.